Section 5.1, Quadratic Functions. In this section, you're going to recognize characteristics of parabolas, also known as quadratic functions, understand how the graph of a parabola is related to its quadratic function, determine a quadratic function's minimum or maximum values, solve problems involving quadratic functions' minimum or maximum values. Recognizing the characteristics of parabolas. The graph of the quadratic function is a U-shaped curve called a parabola. That is the famous one. It has an extreme point called the vertex. So we're going to call the vertex, which is h and k. That extreme value could be a maximum or a minimum. The general form of a quadratic function presents the function in the form f of x equals ax squared plus bx plus c, such that a, b, c are real numbers and a is not equal to 0, because if it is, then it's no longer quadratic. It will be a linear function. If a is positive, which is the leading coefficient, the parabola is going to open upwards. It's going to look like this, and the extreme point, or the vertex, is going to represent a minimum value of the quadratic function. If a is negative, in other words, it's going to open downwards. So it's going to look like this. That is, if the leading coefficient is negative, then the vertex is going to represent the minimum value of the quadratic function. The vertex is a turning point on the graph, as you can see here. It is going to turn from increasing to decreasing, or from decreasing to increasing. The graph also is symmetric with a vertical line drawn through the vertex. That line is called the axis of symmetry. So here is the axis of symmetry, as you can see here. It cuts the graph into two equal shapes, and that is why it's called the axis of symmetry. On the graph here, notice that the minimum in this case is called the vertex. We have the axis of symmetry, and we have what we call the y-intercept, which is where the graph intercepts with the y-axis. Also, we're going to have two x-intercepts. So we're going to have two x-intercepts for the parabola. The y-intercept is the point at which the parabola crosses the y-axis. You can find the y-intercept by setting x is equal to 0 and then solving for y. So that is how you're going to find the y-intercept. The x-intercepts are the points at which the parabola crosses the x-axis. And the x-intercepts represent the zeros or roots for the quadratic function. And you can find these values by setting f of x or y equals to 0 and then solving your quadratic function with your favorite method. That could be by factoring, or by the quadratic formula, or completing the square or square root property, etc. Here is an example. If you have y equals x squared plus 4x plus 3, then the value of a is 1, the value of b is 4, the value of c is 3. We notice here that a is bigger than 0, or positive, so a is positive in this case. The parabola is going to open upwards, so we know that just by observing the equation. In order to find the y-intercepts, we're going to set x is equal to 0, and then we're going to solve for y. If we do that, you're going to end up with y equals 0 squared plus 4 times 0 plus 3. You'll end up having the value of 3, which will give you y equals 3. So we write the y-intercept as an ordered pair, where x is 0, y is 3. When x is 0, y is 3. In order to find the x-intercepts, we set y equals to 0, or f of x is equal to 0. So we get x squared plus 4x plus 3 is equal to 0. If you factor that, we need two numbers. Their product is 3. Their sum is 4. That is positive 3 and positive 1, as you can see in the factoring right here. And then you're going to set each factor equals to 0 and solve. You will end up with x is equal to negative 3 and x is equal to negative 1. So we're going to write the x-intercepts as ordered pairs again. That is, when y is equal to 0, x is once equal to negative 3, and once it is going to be equal to negative 1. Here are formulas that are very important for the quadratic function. So We will need to find the vertex for sure for the quadratic function. The formula for that is the vertex is h and k basically. So the h value is going to be computed using this formula. H is equal to negative b over 2a. In order to find k, we're going to take h and plug it into the function, and we compute k. The axis of symmetry is the equation x is equal to h, so once we found the vertex, we will be able to find the axis of symmetry. The standard form of the quadratic function, so let's say we were given the vertex and we were given a point on the graph, we will be able to determine the equation using the standard form of a quadratic function, which is f of x is equal to a times x minus h all squared plus k. A is the leading coefficient. Sometimes it's not given, but we can find it if we are given a point on the graph along with the vertex. You can find the y-intercept by setting x is equal to 0 and solving for y. You can find the x-intercepts by setting y or f of x equal to 0 and solving for the quadratic equation, or solving the quadratic equation you're using your favorite method. If a is positive, the leading coefficient is positive, we have a minimum of k at x is equal to h. So the minimum value can be found by finding the vertex, and the minimum value is going to be the k value of the vertex, and the position of that is at x equals h of the vertex, so the h part of the vertex. Similarly, if a is negative, then we have a maximum, and the maximum is located, the maximum value is k, and it's located when x is equal to h. So that is going to depend on finding the vertex. So you're going to find the vertex before you determine a maximum or a minimum. Here are some examples. Rewrite the quadratic function f of x equals x squared plus 4x minus 3 in a standard form, or also known as vertex form, which is f of x equals a times x minus h squared plus k, and give the vertex. And then we need to find the vertex. So we will need to find the vertex first in order to determine the standard form. So let's first determine a and b and c. A is equal to 1, which is the leading coefficient. B is equal to 4, which is the coefficient of the linear term. And then c is equal to negative c, which is basically the constant term. We will find h. H is negative b over 2a, so we're going to substitute here. Negative times b is 4 over 2 times a, which is 1. That is equal to negative 4 over 2, which is negative 2. Now, in order to find k, we know k that we plug h into the function. So we found h to be negative 2. We're going to plug it back into the function and evaluate the function at h. So this is going to be negative 2 squared plus 4 times negative 2, don't forget your parentheses, minus 3. This will lead to k is equal to 4 minus 8 minus 3. And that is going to give me k equals 4 minus 8 is negative 4, minus 3 is negative 7. So that is the vertex. So the vertex here, I can say that the vertex is equal to h, which is negative 2, and negative 7, k. Now, I know that the a, which is the leading coefficient, is equal to 1, so I do not need to solve for that. Now, the standard form, f of x equals to a, which is 1, times x minus h minus negative 2, all squared, plus k plus negative 7. I'm going to make it a little bit prettier, so I will simplify. I will have x plus 2 all squared, negative times positive is minus. So minus 7, and that is going to be the standard form of the quadratic function given to us. I will do another example. Rewrite the quadratic function f of x equals 6x squared plus 12x plus 6 in a standard form, and give the vertex. So same thing, I'm going to identify a. A is 6, b is 12, and c is 6 as well. First, I'm going to find h is negative b over 2a. So that is negative 12 over 2 times 6, which is negative 12 over 12. That is negative 1. K is basically f of h. So f of negative 1, that is 6 times negative 1 squared plus 12 times negative 1 plus 6. So I will get 6 times 1 is 6 minus 12 plus 6. And that is equal to 0. So the vertex in my case here is h, negative 1, and k, which is 0. And now I would put it in a standard form. I know that a is equal to 6 in my case, because that is what the leading coefficient is. So the standard form is going to look like f of x is equal to 6 times x minus h, negative 1, all squared, plus k, which is 0. So the standard form is going to be f of x equals to 6 times x plus 1 all squared. And that's the standard form here, the answer for the second part. Question number 3, determine whether f of x equals 6x squared plus 12x plus 8 has a minimum or a maximum, and find the value of the minimum or maximum. Also find the axis of symmetry. All depends on the vertex. First, let's determine if we have a maximum or a minimum. So since a is equal to 6 and b is equal to 12 and c is equal to 8, I know that since a is greater than 0, then we have the parabola is going to open downwards and we're going to have a minimum. What is the minimum value? It's the k value. But in order to find k, we will need to find h first. So let's find h. h is equal to negative b over 2a, which will be negative 12 divided by 2 times 6, which is equal to negative 1. K is f of h, which is in this case negative 1. So I will substitute it. It will give me 6 times negative 1 all squared plus 12 times negative 1 plus 8, which will give me 6 times positive 1 is 6 minus 12 plus 8 equals positive 2. So k is equal to positive 2. In other words, the vertex is equal to, let me write it here, is negative 1 and 2. So h and k. We know that the minimum is equal to the k value, and it happens at x is equal to h. So we're going to say minimum is equal to 2 at x equals negative 1. So that is how we're going to state the minimum. Now, we're going to find the axis of symmetry. We know that the axis of symmetry is x is equal to h, which will lead to x equals to negative 1 in this case. And that is the axis of symmetry. So let me just highlight that. So the axis of symmetry is x is equal to negative 1. It has to be an equation. Question number 4. Determine whether f of x equals negative 4x squared plus 16x plus 2 has a minimum or a maximum, and find the value of the minimum or maximum. Also find the axis of symmetry. So in this case, here is the equation. I have a equals negative 4, b equals 16, and c is equal to 2. Since a is less than 0, then we have a maximum, because the parabola opens upwards in this case, so we have a maximum. So in order to find the maximum, we need to find the vertex. So we're going to find h. h is equal to negative b over 2a, which is negative 16 over 2 times negative 4, and that is negative 16 over negative 8, which is equal to 2, positive 2. Now, in order to find k, we're going to plug h back into the function. So f of 2 is equal to negative 4 times 2 squared plus 16 times 2 plus 2. So we will have negative 16. Negative 4 times 4 is negative 16 plus 32 plus 2. So we will have here 16 plus 2, which is 18. So the vertex is equal to 2 and 18. Now, the reason why I write out the vertex is because it helps me it helps me determine what the maximum is. So we're going to have a maximum. The maximum is 18, which is the k value, at x equals to 2. At x is equal to 2, which is the h value. So that is basically the maximum that we found. Next, we're going to find the axis of symmetry. So the axis of symmetry is x equals the h value, which is in this case 2. So that is the axis of symmetry. And that is how you're going to use the vertex to determine all of these values.